All right, welcome back. Dr. P here, and in this video we'll take a look at reactions involving carbonyls, aldehydes and ketones that we've seen so far. So we have seen some ways of preparing aldehydes and ketones. So what have we seen? Well, we've seen oxidation of alcohols. So for example, we've got oxidation of alcohols. And if we have a primary alcohol and we oxidize that using something like PCC, the text refers to a different reagent. I think it's called the Dress reagent, but it's another gentle oxidizing agent. You'll get RC double bond O. We've got an aldehyde. That's our primary alcohol. If we start with a secondary alcohol instead, and we do oxidation, and in this case we can be a little more vigorous. We could use chromic acid, permanganate, something like that. We'll get RC double bond O, R prime. We'll get our ketone. So those are the ways that we've seen of making aldehydes and ketones from alcohols. Now we've also seen some other ways. We saw oxidative cleavage of alkenes. And in this case we'd have something like let's see, we want to use, if we have an aldehyde and we want to stop at the aldehyde, we want to use ozonolysis. So O3 followed by DMS will give us R prime plus R double prime. Permanganate oxidation will work if we just are using ketones, or if we have a tetrasubstituted and we don't, because permanganate will keep oxidizing this guy there. Let's see, what else have we seen? We've seen hydration of alkynes. And let's see here, I think it was what, Hg2SO4, is that right? And H2O. Just make a note here, double check reagent. I'll have to double check that. We would get R, C, double bond O, CH3. And so that's our Markovnikov. We could also do an anti-Markovnikov, which is using 9BBN followed by H2O2 and OH minus RCH2C double bond OH. There we go. So that's to get an aldehyde. All right. Let me think if there were other ways that we've seen of making aldehydes and ketones. We've got oxidation of alcohols, oxidative cleavage, hydration, oxidative cleavage of alkenes, hydration of alkynes. I think that's all that we've seen so far. We've also seen a couple types of reactions involving aldehydes and ketones. So let's look at those. I should say reactions of aldehydes and ketones. These other ones involve them as products. All right. The first one is that we've seen is oxidation of aldehydes. So if I have R, C, double bond O, H, and I do some kind of oxidation that's more strenuous than PCC or the Dress oxidizing agent, we'll get a carboxylic acid. Now, ketones do not undergo this type of oxidation. All right. Let's see. We've seen reductions of aldehydes and ketones. We've seen reductions to alcohols. So if I have R, C, R prime, double bond O, and I do NaBH4 and water or methanol or something, I'll get R, C, H, OH, R prime. And we can use 1LiAlH4 to H2O instead. So that would be another reducing agent that we could use. And this works for both aldehydes and ketones. We've seen a reduction to alkanes. So one example is the Clemenson reduction. And that gives us RCH2 R prime. And then the other one that we've seen that I mentioned last time, and we'll mention it again, we might go into a little more detail. I'm not sure if I want to actually go over the mechanism or not, but the Wolff-Kishner. So that's under different conditions, basic as opposed to acidic, and we'll see why this may make a difference. So again, this is our Clemenson. And this is the Wolff-Kishner, in case you were wanting the names. We also have, separate this here, we've seen some nucleophilic addition to carbonyls. For example, we've seen the Grignard. Where I would have R, C, double bond O, R prime. Treat that one. Let's do R double prime MgX. BMGBr, whatever, followed by H3O plus, gives me R, C, R prime. We've added the R double prime and we have an OH there. Really, that's what these reductions are as well. We're just using a hydride ion, H minus, as our nucleophile. We could also use cyanide as our nucleophile. So I'd have RC, double bond O, R prime. And then I could treat this with one, say NaCN, 2 H3O plus, gives me R, C, C, triple bond N, R prime. Whoops, damn it. Let's get rid of that. OH. Sorry about that. Ignore that. That was supposed to be a single bond there. Ignore that guy right there. Ignore that. Okay, that should be a single bond. Let me redraw that for you here. R C O H R prime C triple bond N. All right, and then the last one that we've seen would be acetylides as nucleophiles. So acetylide nucleophiles. So I could have my R, C, R prime, double bond O, and then I would treat this with R, double prime, C, triple bond C, minus Na plus, 2 H3O plus. That now gives me R, C, R prime, OH, R, oops, sorry, C, triple bond C, R, double prime. Whew, squeeze all that in there. Sorry about that. So these are some nucleophilic attack that we've seen on carbonyls already. We talked a little bit about it, about why it happens. We've got a good nucleophile. We've got negative charge on a carbon here. We've got a very polar bond here that functions as a carbanion, a negative charge on a carbon. Here we've got a negative charge on this ion is predominantly on the carbon end, and there's a lone pair there as well. And of course these hydrides are H minus, H with a lone pair. So we've seen a few reactions involving aldehydes and ketones. And what really I'm going to focus on in this chapter is more nucleophilic addition reactions to aldehydes and ketones. And we'll start that by looking at oxygen as a nucleophile in the next lecture video. All right, stay safe out there. Bye now.